Everyone, and welcome back for the final question we're going to be doing in 38-2. At least in these videos, you'll do some on your own. This is problem number 6. You'll see we skipped 5. I think that's going to be one of your exit tickets, so you'll do that on your own. All right, so this problem is also spanned over 2 pages. It starts on 562, and then again, the page break goes to 563. It's kind of annoying that you have to flip back and forth, but it is what it is. All right, so let's take a look at what we have here. Let's read the scenario. A store has 48 different phones available with or without caller ID and with or without speakerphone. The number of phones with and without these features are shown in the two-way frequency table. Basically, two-way tables have columns and rows. And then when you add the word frequency in there, it means how often those things happen. So each one of the numbers in the table represents how many of those you have. So for instance, that 18 I highlighted represents there's 18 phones that are both caller ID and speakerphone. Right? And then you have 2 phones that are caller ID and not speakerphone. And then what this does is add them together and say, okay, well, I got 18 with caller ID and speakerphone plus 2 with caller ID and no speakerphone. So there's a total of 20 phones that actually have caller ID. Right, so what they do is they add the totals going across. Right, the total caller ID is 20, the total non-caller ID is 28, and then you add those two together for a total of 48 phones. Right, and then you could do the same thing going through the columns instead of the rows. So speakerphone 18 with caller ID, 16 without caller ID for a total of 34 speakerphone phones. And then, non-speakerphone have 2 with caller ID, 12 with no caller ID for a total of 14 non-speakerphone phones. And then you can add those for a total of 48. All right, so that's kind of how you would break this table down. So let's go through the problems and we'll see, a little more detail what's going on. How many of the phones have caller ID? So we kind of answered that already, but when you're doing something like this, you could look at the table and say, okay, caller ID is this row right here, so I want the total for that, which is 20. Right? And the way they got that again was they did the 18 plus the 2 equals a total of 20. So 20 phones have caller ID. All right, and then it says, what is the total number of phones that is available in the store? There's a couple ways of doing this. First way is they actually tell you 48 if you read the paragraph, so we know there's a total of 48 phones. Or you add the total to find the total. So the total on the rows was 20 caller ID, 28 no caller ID for a total of 48 phones. Or you can add the speakerphone and non-speakerphone phones, so you get 34 with speakerphone plus 14 without a speakerphone for a total of 48. All right, so what you want to do to find the total is you either look in that bottom right corner box with the 48, or you can add the totals of either the rows or the columns. All right, so regardless, there is a total of 48 phones in this particular problem. All right, so now what they want us to do is to find some probabilities. So if the phone is chosen at random, what is the probability that has caller ID? And now they want us to even use a calculator and find the decimal rounded to 3 decimal places. I think you've already done some rounding practice, so hopefully you're comfortable with that. In all reality, probability is okay as a decimal, but numbers are better as fractions. They're more accurate, whereas the decimals are going to be approximations because you're rounding them, so it's not as accurate as a fraction. All right, so probability is going to work the same way. We were doing those other problems with the contestants. There was a total of 12 contestants, so that was the denominator in the probability, and that's going to be the same thing here. In this case, there's a total of 48 phones, so that's going to be the denominator in our probability. When I'm doing any kind of math problem, I like to put in the information. That's probably the easiest to find. We just found the total, so let me just throw that in there. So now I just need to worry about, in this case, the numerator, which would represent how many phones have caller ID. Right, that's kind of what we're looking at here. That's the scenario they're giving us, phones with caller ID. So what I'm going to do is I'm going to go over to the caller ID row, and I'm going to look at the total, which in this case is 20. So the probability of getting one of these phones at random and having caller ID is 20 over 48. Now, that can be reduced, and that's something you should do, but in this particular case, they actually want us to give a decimal answer and not a fraction, so I'm not going to bother doing that. And if you grabbed a calculator and rounded it correctly, you should get 0.417. Right? And you'll notice this little thing here, that's an approximation sign, right? So it's no longer equals because we rounded it. So it is approximately 0.417. Right? So the way you found that was you divided 20 by 48, in case you're wondering. All right, so let's go through the next problem. The phone is chosen at random. Find the probability that it is I. So each of these are, different problems. Speakerphone. So we all know the probability has a speakerphone. Well, guess what's not going to change? The fact that there's 48 phones. And that's not going to change for the next problem, or the next problem, or the next problem. No matter what problem we're doing, there's going to be 48 phones because we're talking about out of all the phones in the store. Right? So that's something that I can go ahead and get out of the way. And then I just got to go through and read the table. So the first scenario is going to be speakerphone. So I want to know, hey, how many phones have speakerphones? And I'm going to go to that table, find the speakerphone row, find the total, and that's going to be my numerator. So in this problem, there are a total of 34 phones that have speakerphones out of the total 48. So 34 divided by 48 would give us approximately 0.708. So that would be our probability in part DI. All right, and then, we're going to go through and do the next one. So now we want to take a look at speakerphone and caller ID. So now we need to have both of these things in our phone. So we're going to go back up. We got the speakerphone and caller ID. So remember, caller ID was this row here, and speakerphone was this row here. So what we need is where both of these things are happening, which again is the intersection of the red and the blue, which gives us that purple one, which is going to be right here. Right, so there are 18 phones that have both speakerphone and caller ID. Right? So remember, you're looking at the intersection, which was just this one cell right here. So that's going to be our numerator. So for part D2, we have 18 over 48. And again, if you had a calculator, you would divide 18 by 48. And in this case, it's actually not an approximation because it is exactly 0.375. So I would use a normal equal sign since that's what it came out to when we used our calculators. All right, so the next one, speakerphone but does not have caller ID. So the same thing, we're going to go back up to here. We know we still want speakerphone, so that's going to be the same column as before. But now we don't want caller ID, so that would be the other row, which is this one right here, right, which might be a little hard to see. So the intersection of those two would be this one right here, right? 16 that have speakerphone but don't have caller ID. So we're going to go ahead and put that in there, 16 out of 48. And again, it was N, so we needed both of those things to happen. And that would be 0.333 when rounded to 3 decimal places. And that's not exact, that's being rounded, so it's approximately. So we're going to keep that approximation sign. All right, now, the trickiest one I think to do from a table is the or, and I'll show you why. So now we're looking at speakerphone or caller ID. So let's go ahead and take a look at the table, speakerphone or caller ID. So again, we have speakerphone, which I'll do in red, or caller ID, which is blue. Now, it could be any one of the blocks in those rows and columns. And I'm going to erase the totals, right? Because we want to focus in not on the totals of anything, but the individual cells that we're talking about. So it could be that they have both caller ID and a speakerphone, which is that cell there. Or maybe, it has just the caller ID and doesn't have a speakerphone, which is okay because it could be either one and it has the caller ID. Or maybe it does have the speakerphone, which we want, but no caller ID, which again is okay because it has one of them at least, right? It could have one or both. Now, those are the three cells that represent what we're doing. And if I add those together, right, I'm going to get, 18 plus 2 plus 16, which is 36. Okay? We have 46. Nope, 36 was right. Shouldn't second guess myself. All right, 36. Now, where you can get into trouble with a problem like this is if you thought you could add the totals to get here. And if I say, oh, okay, let me take a look. Well, I have a total of 34 speakerphones and a total of 20 caller ID, which is 54, which you can see is not the same thing we got. And the reason that you can't add the totals is because if I add this total of 20 over here, then it was the 18 plus the 2 to make 20. And if I did the total of 34, it's the 18 and the 16 to make 34. Well, the problem is I've counted that 18 twice in this scenario. Right? So if you use the totals, anything that has both of what you're looking for, caller ID and speakerphone, is going to get counted twice. So you could technically add the totals if you did the 34 plus the 20, but then you'd have to subtract out anything that is both of these. So if it's both speakerphone and caller ID, I don't want to count that twice, so I have to subtract one of them out. And that would still give you the 36. So I think it's easier to not even really do it that way. Don't really worry about the totals too much. Just go through and find all the cells that fit and add all those numbers together. So 18, 2, and 16 for a total of 36. So that's what we're going to put here. 36 out of 48. But they want you to find the decimal. So 36 divided by 48 is exactly, so I don't need the approximation sign, 0.75. All right, and I know it says around the 3 decimal places. You don't have to put the 0 after the 5. You could just leave it as the 2. Okay,